information that HTTP offers. In addition, we'll provide you a table of tracked items. So we have badges and cubes and blocks, and all of them are tracked in a couple CSV files. So if you want to do immediate correlation with those files, you feel free. And then lastly, I'll just finish up with, we have developer.impinj.com. Certainly feel free to go to there for API details and instructions, in addition to some Java libraries, as well as Node.js libraries, and a already built Angular Node-based visualization tool that you guys can leverage, copy, fork it, whatever you guys want. So with that, I'm just going to go to the GitHub site and just show you what we got. So here's the Viz tool. This is really a compilation. This is an actual tool. And then you have the item sense Java libraries, which I'll just go to that. From there, we also have, it's all listed on Maven Central. So if you want to use these libraries, you feel free to do so with your Pojos, or in Node.js, same thing, and go from there. With that, I'm going to go ahead and hand back the ball to Mr. Grundy and team.
Awesome. Thank you. That was amazing, Bryan. So one question that came up just for myself is for associating new tags. We're going to have some tag packs from SmartTrack as well as some from Vanguard. We're setting up an association station, I guess?
Yeah, that's 100% accurate. I have an encoding station as well if we want to encode it with a specific, some specific EPCs, or we can just basically read them and note them down in a CSV file.
Got it. Okay, great. So that's going to be totally helpful, so that people can kind of kludge things together. So we can open up. We have 1 minute. If anyone wants to post questions to Bryan now, if not, you can just throw it onto the chat window, and I'll get those to him later on. So next up, we have. Let's see here. Next up, we have Nabila from Plantronics, and I will share her screen so that she can start setting up. Let's see if I can find it. There it is. All right, Nabila, I will also unmute you. Hold on 1 second. There she goes. All right. Sweet. So I've unmuted you, Nabila, so I should be able to hear you.
Hello?
Yes, we can hear you just fine. Great. I'll mute myself and take it away.
Hi, do you see my screen? And can you...
Yep, I see your screen just fine, and everyone else.
Okay. Okay, sounds good. Hi, I'm Nabila. I'm a developer at Plantronics. And just to give you a quick overview, Plantronics is a very old enterprise headset company, one of the market leaders. It was founded in 1960s, and we have an in-house innovation team called PLT Labs. For this hackathon, we are going to bring one of the latest concept headsets, and in next slides I'm going to give you some overview on what features it has. So this is our latest headset called Wearable Concept 2, or WC2. It's built on top of one of our top-tier Bluetooth headset called Voyager Legend, known for superior noise cancellation, audio quality, things like those. This headset is packed with numerous sensors to give the user interesting events like head orientation, wearing state, pedometer readings, things like those. Two new features we added are FIDO authenticator. So this headset can be used as a second factor security token. So for example, when you log into your email or bank account, if you have the second factor security token activated, it sometimes sends you a text code or an email code that you enter. So this device can eliminate that. You can Bluetooth pair it with your host, and it takes care of the second factor authentication. And another new thing that we added is the always listening mode. So instead of turning it on or off, the headset can be in sleep mode, and you can turn it on by simple key phrase like "Hello Plantronics," like somewhat like "Hello Siri" or "Okay Google," and the headset can understand some of the key commands, such as like mute on, off, or volume up down, or call someone. And we are providing iOS and Android APIs to work with this sensor event. In this slide, all the capabilities that this headset support is listed. So always on listening, or the second factor authentication, are the one I already mentioned. We have acceleration, compass heading, angular velocity, proximity, like you can detect proximity near or far to the host device that the headset is paired to. It supports standard Bluetooth profiles, hands-free protocol, A2DP. The headset also has tap detection, so if you tap on the side of the headset, it can detect that. Free fall detection, some of the interesting features. We do regular hackathons in major cities in the US. Here are some pictures from our past hackathons. For this hackathon, we are looking for second factor security integration, like the projects that include our FIDO functionality, maybe the always listening voice integration, and some of the standard sensor integrations, sensor events that we have. And for prize, we are giving out two of our high-end headsets, Plantronics Rig gaming headset, and the Bagwit Sense. So I would ask everyone to go to pltlabs.com/wc2. This is we have this site for our hackathon purposes, and you can get all the code, APIs, and instruction, and links to GitHub. There we have for both iOS and Android. And just to let you know, we have two different set of sample codes. One covers all the sensor features, including the always listening, and the FIDO authenticator is in a separate GitHub repo, but the links are in this pltlabs.com/wc2. So that's all I have.
Great, Nabila, that was awesome. I think it was really interesting to see the FIDO authentication. I didn't know that was supported. I think that there's some compelling use cases there, as well as one that I was familiar with just from reviewing the website, the PLT Labs website, is the vector. Right. I think that the vectoring feature that the headset carries is one that when combined with the indoor hyperlocation aspects of the Impinj infrastructure, you can get some really interesting use cases. Like walk into a conference room, stare at a wall for 2 seconds, and and suddenly the projector turns on. Things like that. I think that they're solutions that can definitely be built within the the time span of the hackathon, and would definitely be really cool to see working.
Right, and also in this slide, like some of the things we already use, like for example, wearing state. If you take off the headset, the music is automatically paused, or like if you wear it back, it plays. Like those are already there, so there can be many interesting integration with the sensor events that we have.
Right. Like even if you had like Bluetooth speakers surrounding a room, like you take off the headset, everything kind of silences, or you get an incoming call and things silence. I definitely think that there's mashups in that space that are really compelling. Yeah.
Right, and the pedometer for health purposes can be interesting.
Yeah.
Too.
Well, great. Well, again, I really thank you for your time. We can open it up for questions if anyone out there, and sponsors included, if you have questions, feel free to just drop them into the chat window. In the meantime, I will start setting up the next presenter, and just we'll keep moving on. No need to spend more time than necessary. Nadine is up next, so I will start switching it to her. And again, if there's any...
Hey, can you guys hear me?
Yeah.
Okay, cool. Okay. Give me 1 second. Let's see. Okay. Can you guys see the screen?
Hold on 1 second. I think I made a mistake myself. All right, now I'm handing it back to you. Sorry.
Oh, cool. Can you guys see my screen?
Yeah, now I can. Yep, everyone else should see.
Okay, cool.
We're all set. You can start whenever you want.
Awesome. So I'm Nadine, and I'm actually with PunchThrough Design. And what we make is what we call the light blue bean. And essentially, the light blue bean is a Bluetooth low energy device. So it's a microcontroller that has a built-in accelerometer and temperature sensor. And we also have an onboard RGB, or red, green, blue LED. And what's really cool is that you can actually use the Arduino IDE to develop the bean. And we also offer Android and iOS SDK. So if you choose to, integrate a more IoT-enabled product, you have that ability. Let's see. So this slide, what I'm showing you is the certain peripherals that are available to the pins. So pin 0, 1, 2, 3, 4, 5, those are general purpose input-output pins. And then, of course, we have our analog pins, which is A0, A1. And then what I want you guys to know is that below those pins where it says prototyping area, that's actually not connected to the bean. It's essentially like an extension or like a perf board. So that's just to increase real estate for developing. So how do people use the bean? So because the bean is a Bluetooth low energy microcontroller, essentially you can program it wirelessly. So a lot of people, if they choose to integrate a mobile app with iOS or Android, they can build wearable devices or mobile battery power sensors. And actually, we're also compatible with Node-RED and Raspberry Pi. So if you want to integrate APIs, you have that ability to do so.
Nadine, I was sorry to interrupt, but for some reason, it's only showing the keynote screen rather than the different slides. I don't know if maybe it's like in application mode.
Are you seeing it now?
Yes, now I'm seeing it. Yep.
Oh, that's weird. Okay.
All right.
I'll go over really quick. So this is essentially the bean's anatomy, and what I'm showing you here is the peripherals that are available to each pin. 0 through 5 is the general purpose input-output pins. A0, A1 are analog pins. Of course, we have battery and ground. And then below those pins, we have the prototyping area, so it's disconnected to the bean, so it's just essentially acts like a perf board. And then, so here, how do people use the bean? So if you want to integrate it to mobile devices, you can build wearable devices. You also can build mobile battery-powered sensors. And then if you want to connect to the Internet of Things, we are compatible with Raspberry Pi and Node-RED. Or you can also build a server and transfer your information from your mobile app as a JSON object to the server and then connect to APIs, and then you can do lots of other stuff with that.